All right. This is for homework 17, problem number 7, which is this one. We want to at the particle to be t to be 5. So the best thing to do here is that we have this vector field. Okay, we have at the starting point at negative 2, 3. So the vector at negative 2, 3, plug in x to be negative 2, y to be 3, we get this vector. Now, we know we started out at negative 2, 3. So to figure out where the approximation of 5.04, you take the old position plus your average velocity, which is this vector field, times the time. So from 5 to 5.04 is 0.04. So what I did is I multiplied those two out, and then you add these components and you get negative 2.28 and 3.2. For this problem right here, um, this is the line integral, some on some curve C, which is t, which they gave me the vector right here, r of t. So the dr, the derivative of this is 2t plus 12, 2t, 12t squared, and 2t again. Remember, this is a vector right here. So if I want to integrate this, now I'm going from t to be from 0 to 1. So a is going to be from 0 to 1. And I'm going to take this times dr, which means this times this first vector times this dr, which is 2t, the second vector here times the 12t squared, and this third vector times the 2t. So it's these times your dr. So you have your first, and we're going from 0 to 1, by the way. So dr is this. So this is from a to b, which is from 0 to 1. And you have to do three different integrals. So you end up with your x, which is t squared, plus the y, which is 4t cubed, times your dt for that, which is 2t, from 0 to 1. Then you do the same thing for the second one, 7 times y. Y is 4t to the third, so it's 7 times that, minus z, which is minus t squared, times the dz, which is 12t squared dt. Integrate from 0 to 1. And finally, for the third one, it's negative 3, and z is t squared, times dt, dz in this case is 2t dt. And then you just got to figure this out, each one separately. You can use a calculator or go to Wolfram Alpha and plug it in and figure out what this answer is. In the next problem, same thing. Here we have to do the line integral on this guy times, I, I can barely see this, but it's, here it is. And we're going to go counterclockwise. So to go counterclockwise, the parameterization would be x to be r cosine t and y is r sine t, and t is from 0 to 2 pi. So your vector is, the x is, r is 1. Your radius is 1. So it's cosine t and sine t between 0 and since I'm going from 1, 0 to negative 1, 0, and that would be from here to here. So we're going to go just from 0 to pi is my thing. So from 0 to pi. So again, now I know what x is and I know what y is. Take the derivative. Derivative of cosine is negative sine. Derivative of sine is cosine. And to find this ds, we take the derivative squared and take the square root. This happens to equal to 1. Sine squared plus cosine squared is equal to 1. So now I go back and plug in. I got 4 times x. Well, x is negative sine t. So, I'm sorry, x is cosine t. Sorry, that was the error. X is cosine t. So I got 4 cosine t minus sine t dt. And we're going to go from 0 to pi. And then 0 to pi of negative 3 x times y. Negative 3 cosine sine dt from 0 to pi. These you can integrate each one separately. This is just the regular cosine and sine integral. This one, that u be either sine t and then take its derivative, or cosine, whatever, which way you want to do it. It really doesn't matter. And then you integrate from 0 to pi. I came up with -4, but I did this real quickly. So, but these are integrals from 0 to 4. Uh, I know this is correct. Okay. Same problem here. We are going to this force field and moves along the x equals y squared plus 6. So first of all, we're going from 6 to 15. So I'm going to change everything in respective to x. I mean, you can keep it in t, but it was easier to keep it in x because x goes from 6 to 15. So this is how I did from a to b. So I took this equation and solved it for y. So y is the square, x equals y squared minus 6. Y equals the square root of x plus 6. Its derivative would be dx over 2 square root of x plus 6. So here, then I went to here, and I said, okay, it's negative 3x squared with respect to dx, and y e to the x dy. Okay, well, this is dx. What is y? Y is this thing. E to the x, what is dy? Dy, we found out to be dx over this. So this reduces to negative 3x squared. These cancel out. You get 1/2 e to the x dx. And this is just, and again, it's from 6 to 15. And this is just an easy integral. And you end up with this. I didn't get the answer, but that's what that was. This one, same idea, same approach. We have to parameterize this thing. So I let x to be t, y to be 1 plus t squared. And we know x goes from -1 to 2. Okay, -1 to 2. So I know I kept things back in the x's. This will be easier to do this. Um, let's see, and we know when we parameterize this thing, it's from 0 to 2 pi. Um, Then I kept this guy right here. I kept x, what it was y. Y was 1 plus x squared. And then I squared that right here. And then I took 3 times y, which is 1 plus x squared, over x squared plus that. And I tried to multiply this out, and it came out to be just so messy. So I just used Wolfram Alpha. And don't forget to plug in from -1 to 2. It gave me an hyperbolic cotangent. That's why it was got so messy. So you can actually do this in, uh, you have to do trick substitution and all this. I just didn't have the time to do that. So I just used Wolfram Alpha, and that's what I got. And finally, the same thing again here. I don't know which problem this is from where it came from, but I want to go from 1, 3 to 4, 4. So we have to parameterize this segment. And to parameterize a segment, the formula is x equals 1 minus t times where you start from, which is 1, plus where you want to end up at, which is 4 times t. And then the y is 1 minus t, where I start from, which is 3, plus where you want to end up times t. So those reduce to those, and that's from 0 to 1. So now you have your x, you have your y. X prime is 3, y prime is 1. So I took this curve right here, and it was 7 times x. X was 1 plus 3t, plus sine of y. Y was 3 plus t. And I got to get the dr, this ds. ds is the square root of the primes squared. As you see, the prime was 3, the prime was 1, 3 squared plus 1 squared. You get that, dt. So this now becomes a fairly simple integral. 9 plus 1 is, I did the square root of 10, integral from 0 to 1. I distributed all this out so that you can see it, and you can do each one separately. I didn't do, again, the answer, but that's what that would be. I hope this helps you